Alright, so now we get into section 8.3, where in 8.2 we were talking about just simple rational functions. Now in 8.3 we were able to graph general rational functions. General rational functions can be represented in the equation here, where it's a sub m times x to the m power divided by blah blah blah. It's a lot of mumbo jumbo, which may look confusing, but when it comes into a problem sense, when you're trying to graph a function, in this case, it's really not that bad. There's certain steps that we have to take, just like we've had in all the other ones, in order to graph the functions. Here they are here, and again, here they are here as well. First thing we have to do is we have to find the x-intercepts. The x-intercepts is basically we're going to set our numerator equal to 0 and then solve. Sometimes we'll have x-intercepts, sometimes we won't. It's dictated by setting the numerator equal to 0. By finding the vertical asymptotes, we must set the denominator equal to 0 and then solve. Again, sometimes we can do it, sometimes we can't. But it's dictated by setting the denominator equal to 0. When to find the horizontal asymptotes, here is the kind of the stipulations that we're looking for here. You look for each in the numerator and the denominator, we're looking for the highest degree. M is the highest degree power in the numerator, and then n is the highest degree power in the denominator. And those two values dictate on what it's going to be. So for here, if m is less than n, then our horizontal asymptote is going to equal 0. If m and n equal each other, then the horizontal asymptote is dictated by what constant value it is in the numerator divided by the constant value that it's connected to it in the denominator. And then if m is greater than n, then it has no horizontal asymptotes. So, and then the last step is we plot the points like we've been doing before, you know, keeping values to the left and to the right of our respective vertical asymptotes. So, here I have y equals -2 divided by 2x plus 2. So if I just go to step 1 is I need to find my x-intercepts. We said that we need to set the numerator equal to 0, so I have -2 equals 0. From here, I can't solve that. So since I can't solve that, that means that there's none. There's no x-intercepts that's going to help us out. Step 2 is I want to find the vertical asymptotes. And the vertical asymptotes means I have to set the denominator equal to 0. And if I solve this, I get x squared equals -2. And the only way I can get a value here is if I use imaginary numbers. So since there's no real numbers, there's a no real number solution for this equation here, I can say that there are none, or there are no vertical asymptotes. For 3, we have to talk about the horizontal asymptotes. So that means here I have, this is like saying x to the 0 power, and then the highest degree here I have x squared. So in essence, my m is less than my n. And then that means that my y is going to equal 0. So I'm going to at least draw that. So my horizontal asymptote is going to be y equals 0. And then the last thing is, for number 4, is I get to plot some points. And since I don't have any vertical asymptotes, I can use whatever points I want. So let's say I use -3, -2, -1, 0, 1, 2, and 3. And if I were to plug in these values for x for this equation, I'm going to get values like negative 2 over 11, negative 1/3, negative 2/3, negative 1. So I go what? Negative 2/3, negative 1/3, and then negative 2 over 11. So then put this in here. I get something, plot the points. Something like this. And that's a crappy sketch, but kind of get the picture. As you can see that these graphs on both sides are going to approach y equals 0, but it'll never reach it. And so that's where the function of that graph looks like. So here I have y equals negative x squared divided by x squared minus 4. So first thing I want to do is I want to find my x-intercept. So I got negative x squared equals 0. That means x equals 0. So my x-intercept is at 0. 2, I need to find my vertical asymptotes. How I do that is I just take the denominator and set it equal to 0 and solve it. So I got x squared equals 4. That means x here, because if I take the square root of this, it's going to equal plus or minus 2. So let's write those in there. So I got negative 2 as an asymptote, and I got positive 2 as an asymptote. Okay? Number 3 is my horizontal asymptote, and so it's dictated on the degrees here. They're both the same, and when m and n equal each other, the asymptote is dictated by the coefficient of the denominator divided by the coefficient of the numerator divided by the coefficient of the denominator. Sorry. And so if I take this out, that means it's going to be negative 1. So that means y equals negative 1. So let's draw out that horizontal asymptote. And you notice here from different things, I have 2 vertical asymptotes. So what I like to do is, since I have 2 vertical asymptotes, I'm going to set up 3 different t-charts. All of them are going to be XY t-charts. This first one here is going to be to the left of my far left vertical asymptote, so I'm going to take values there. So I've got like negative 3, negative 4, negative 5. The middle one is going to be dictated in values that are in between the 2 asymptotes, so it would be like negative 1, 0, and 1. And then the last one are going to be values to the right of my asymptote where x equals 2, so I can write that as 3, 4, and 5. So the values that I get for y with those x values would be like negative 0.8, 1.8, negative 1.3, negative 1.2, and the negative 1, I get what, 1/3. 0 is going to be 0, 1 is going to be what, 1/3. 3 is going to be 0.8, 1.3, negative 1.2. So I get to plot these points. So I go to negative 3, negative, well, it looks like right about there. Negative 4, I get something like about that. So it kind of looks something like this in here. The second tier of table charts, so I got what, 0, 0, got negative 1 1/3. So it looks something kind of like this. And then the last one I have, what, 3, negative 4, and looks something kind of like this. So that's kind of what the graph sort of looks like when you're dealing with the different asymptotes. For C, I have y equals x squared minus 2x minus 3, all divided by x minus 4. So first thing I want to do is find the x-intercepts. So what I can do, I can factor this out by using reverse FOIL. by taking what's here. It's x and x, plus and minus, and that numerator is going to be plus 1 and minus 3. So if I use a zero product property, I got x equals a negative 1 and x equals 3. So I'm just going to plot those points knowing that my graph at some point is going to cross at negative 1 and it's also going to cross at 3. Number 2 is I get to find the vertical asymptotes. So that means I got to set my denominator equal to 0. That means that x is going to equal 4, and that means I get to write in my asymptote where x equals 4. Number 3 is they want to find out what my horizontal asymptote. So my highest degree in the numerator is 2, my highest degree in the denominator is 1, and since m is greater than n, we look back in what we had in our first page. When m was greater than n, we'd realize that there were no horizontal asymptotes. Okay? So I don't have to mark it. And then the fourth thing is I'm going to make my t-charts. And since I have just the one vertical asymptote, I'll make 2 of them. One of them is to the left-hand side, and then the other one's to the right. And I'm just going to make values, let's say like 3, 1, and negative 2. And then over here I'm going to have like, say, 5, 8, and 10. And if I take those values, I'm going to get 0, 1.3, and what was it, negative 5, 6. And then here I have 12, 11.25, and I got 12.8. So I already plotted the 3, 0 because that's one of the intersections. 1 and then 1.3, so I'll say that's right about here. And then negative 2, negative 5, 6, or something like that. So that first part of the graph is going to look something kind of like this. And then the next part, I'm going to have 5 and 12, so that's somewhere up here. I got 8 and 11, so that's something up there, and then 10 and 12, so it's kind of out the graph a little bit, but you kind of get the idea of what we're trying to do. So that's where we get the graph for this particular function, and that is graphing, or being able to graph general functions, or general rational functions, and being able to figure out the different steps in order to find these systems. So hope it helps. Till next time.